And we're on Unit 3, Lesson 2, and there will be some activities to do during class that will kind of solidify some of this stuff. But the first example that we're going to do is two parabolas have the same x-intercepts, minus 2, 0 and 4, 0. The maximum or minimum value of the first parabola is 2 times the maximum or minimum value of the other parabola. Sketch these parabolas on the same coordinate grid. So my question to you is there only one right answer, or is there possibly a couple of right answers? So what the two parabolas have in common is that they have x-intercepts of minus 2, 0, so 2 to the left, in order x first, y second, just because I know a couple have had a little trouble getting that backwards. And the second point is 1, 2, 3, 4 there. So both of these parabolas share those 2 points in common. It doesn't say whether they open up or down. All it says is whether one is twice as big as the other, so we get to make a choice. I'm going to have mine open down. And it says that the maximum or minimum value, so mine, because they open down, will have maximum values. And the one is 2 times the value of the other. So if I choose to have one of my maximums at a value of 3, for instance, then the other one would have a value of 6. Or one would have a value of 3, the other would have a value of 1.5. There's a lot of possibilities here, so there is definitely more than one right answer. I just need to put my maximum values at the correct place, and I know that the vertex lies exactly in the middle of my two x-intercepts. So exactly in the middle is a value of 1. Now I can see that really clearly on my graph, but another way to find that axis of symmetry line is to look at the two values minus 2 and 4 and average them. So what is the average, or the middle, of minus 2 and 4? If we didn't happen to have a graph, I would add those two numbers together and divide by how many things I have, which is 2. So I have negative 2 plus 4 is 2. 2 divided by 2 is 1. X equals, and that's the average, because it's a line straight up and down, we would write it as x equals 1. Y could be all sorts of things. So this line dotted is x equals 1, and my maximum would have to lie on that line in between the two x-intercepts. So my parabolas would be there and there. I'm going to draw it as best I can. My step pattern is kind of strange. And we won't calculate the value of a just now, but you can see that I could have come up with all sorts of possible parabolas that have those x-intercepts, and my green and blue shouldn't intertwine like that, but anyways, have twice the value of the maximum. For the second example, we have been asked to graph y equals 2 times x plus 1, x minus 2. So I want to have some key features in order to put marks on my graph and then fill in the curve later. So I see this form is in factored form, and it's going to be able to tell me where my x-intercepts are. So my x-intercepts are where y is 0. There is potentially 2 of them, not always. We know that from the first unit. My first one comes from this bracket, and I know that x-intercept would be negative 1. So negative 1 there would give me a 0 in that bracket. My second x-intercept is from the second bracket, which would be a value of 2. So I'm going to put those two key features on my graph, negative 1 and positive 2. I know that there's an important line running down the middle, which is the axis of symmetry. I can see it, that it's going to be at 0.5, right between those 2 points. But just to show my work, I'm going to say I want that vertical line that is in between negative 1 and 2 So I'm going to average them just to prove. Negative 1 plus 2 is 1, is 1/2, just to prove that my eyes are true. X equals 1/2 is right in between. So my maximum or minimum value for this parabola is along the line x equals 1/2. I know some other things from unit number 1. That too tells me, because it's positive, it opens up. And I know that it is skinnier. It would have a vertical stretch factor 2. My goodness, that would be hard to figure out when you've got a vertex on a halfway point. That would be just nasty. So I would rather have a point for my vertex than try and guess at that step pattern. So I am going to look for the vertex with the information that I have. I know the vertex is on that line, x equals 1/2. So I know my x value of my vertex. Well, that's not so bad. I can substitute x equals 1/2 into my equation and find the matching y value, which will be that point on the parabola, which is my maximum or minimum. In this case, it's going to be a minimum because it opens upwards. Okay, if I put 0.5 into that equation, I have y equals 2 times 0.5 plus 1. And 0.5 subtract 2. So I'm going to find the point on the parabola when x is 0.5. 1.5 and negative 1.5. Interesting. Sorry, boo-boo. 2 times 1.5 times 1.5 is 4.5, and I have a negative sign in there, so negative 4.5 is a point on the parabola, and I know it's going to be my minimum point because it's where it hits the axis of symmetry. 4.5, I can just barely fit it on. There we go. There's my vertex. It should look skinny and open up, and it does. And there is my graph using key features. Last one, we're going to graph y equals negative 3x squared by plus 12 by factoring and determining the vertex. I'm going to do you one better. We're going to find one more thing in this form, which is standard form. The number all by itself in the end is your y-intercept. When x equals 0, y equals 12, so I've got a point I can use. I'm going to make every grid here worth 2 so I can fit that important point on there. Okay. There is a point. It has suggested that we factor. Putting it in factored form will help us find the x-intercepts. All right, my thought process is there a greatest common factor? Yes. I'm going to take out a greatest common factor of negative 3 so that I can have x squared as a positive in my bracket. What does negative 3 multiply by to get the positive 12? Well, I'm going to need a negative in my bracket so that negative times negative is positive, and I need a 4. You should always pause and look at your brackets and ask if you can go any further. The next thing I would ask myself is it a difference of squares? Yes, this one is. Two things with a difference sign between them. I can factor this as a difference of squares. With a difference of squares, I want the root of the first with a positive and a negative sign, and the root of the second, and I have a lovely difference of squares where the outside and inside term cancel. This is fully factored. It tells us that our two x-intercepts are both where y is 0. The first one is negative 2, and the second one is positive 2. So I have that y-intercept. I have, taking the same scale, I have an x-intercept of 2 and one of -2. I know that this opens upside down because in both forms I have an a value that's negative and 3. It looks to me like the y-intercept would also be the maximum value because my axis of symmetry would lie between 2 and -2, which is at 0. So coincidentally, my y-intercept is also my vertex, and I can draw it.